Question: in order to calculate power loss due to voltage drop of a PV source circuit, which is the most important factor to consider? VOC, VMP, ISC, and temperature coefficient of VOC. All right, did you take your guess? Did you take your educated guess? Or do you just know? So one of the things about voltage drop is it's not a safety thing, it's an efficiency thing. And so we don't look at things like VOC, which means turned off, which is the highest voltage, which is a safety thing because you don't want to get the voltage too high. We don't look at things like ISC because that's a safety thing, that's short circuit current, and we size our wires based off short circuit current times 1.25 and throw another 1.25, and that's a 1.56. That's right, 1.25 squared is 1.56. That's not what we're looking at right now. That's a safety thing along with temperature coefficient of VOC. So that's what you use for string sizing. When your PV system is turned off on a cold day, your VOC gets even higher. And so you string size for safety so that you don't go over voltage, which would be 600 volts residential, 1000 volts on other buildings, and 1500 volts on the ground, like most utility scale systems. So obviously, the only thing here that does not have to do with safety is VMP. Another thing that you would use for voltage drop would be IMP. That's voltage at maximum power and current at maximum power. Those are all the things that you do to consider voltage drop. And I know because about 10 or 15 years ago, something like that, and something depending on when you're listening to this video, I wrote an article on voltage drop, and we actually call it voltage rise because the voltage is higher from where it's going than where it's going to. And with PV, you have things going in the opposite direction that people are used to, like electricians and things like that. And that's right, we're using VMP and IMP and things like that to consider for voltage drop, which is an efficiency thing and not a safety thing. Safety things, we worry about VOC and ISC and temperature coefficient of VOC. So we're talking about voltage drop, and voltage drop can be converted to voltage drop percentage. And then you have voltage drop percentage, and that's proportional to power loss. A lot of times PV systems are designed so there's no more than 2% voltage drop, but it can really depend on how far you got to run the wires and things like that. Because if you have to go a really long distance, maybe it's worth it to have a little bit more voltage drop to save some money on instead of having a big super thick wire. And if you're going a super short distance, 2% I would think would be too much. And so here it is. It's Solar Professional Magazine. If you want to go to SolarSean.com, we made an index of all the articles in every Solar Professional Solar Pro magazine that was ever published. You could find that at SolarSean.com. That's Solar SEAN. And so this one was over 10 years ago, June, July 2012. And you can see voltage rise considerations. And then we're going to find this character right there, Sean White. And then we can see this article about voltage rise, and it's kind of complicated. I tried to write it a little bit simple, and then those super smart editors, they made it a little bit more complicated. So it was kind of like over the heads of people that are not engineering systems and things like that all the time. Hey, there's a smart guy. They got a quote from him, John Berdner. Anyway, we're not going to go through this article because we could spend a long time here. And this would be beyond the scope of most NABCEP exams, including the PV technical sales. Hey, look at that. Way back then, over 10 years ago, I had a class on June 2nd in Lafayette, California. And there it is. That's my old website. You can check it out, SeanWhiteSolar.com. There we are in the Philippines. Okay, back to this voltage drop question here. And so once again, just kind of like skimming over this article, voltage drop is for efficiency. VOC and ISC are not efficiency things. And voltage drop actually has to do with Ohm's law. That's from George Ohm. And it has to do with voltage drop equals current times resistance. Then you would calculate your voltage drop here. And once you figured out your voltage drop, then you would compare that to the VMP, voltage drop divided by VMP times 100, gets you your voltage drop percentage. So there we go. Voltage drop, current times resistance. And remember too, that more resistance for a wire is a wire, or we call a wire a conductor, that is skinny and long. So a skinny and long conductor has more resistance. Therefore, it has more voltage drop. And that's not a good thing. We don't like too much voltage drop, but we also don't want to pay for a wire to be too thick either. And so your voltage drop, you could take voltage drop divided by voltage, which can be VMP or something near VMP, times 100 gets you your voltage drop percentage. And then if you want to go deep to get one of those real fancy NABCEP certifications or something like an engineering degree, you can go in and read this article. I remember when I was first studying this solar stuff, one time there was this article in Solar Pro magazine that was 2 pages long, and I spent weeks studying it. It was called Calculating Three-Phase Line Currents, something like that, by Marvin Hammond. And this is it for this question. Just remember that B is the right answer. Be good to yourself and pick VMP, that's your maximum power voltage, or IMP, when you want to figure out what you need to calculate voltage drop percentage, anything like that.